Okay, interpreting quadratic equation roots. Listen to me talking slowly so you can finish your conversations and zone in with me. Yes? Because I'm on video, so I can't say those 2 words I usually say. Yeah? Learning goal. I will be able to determine the number of solutions a quadratic relation will have. Let me just add something to that. As quick as possible. I'm going to show you some techniques to be able to go, oh, I know how many zeros there are, without necessarily doing all the work. Mr. Todd, couldn't I just do all the work if I needed to? The answer is yes. You could just do all the work. That could be a time problem on a test or something like that, but you could always just do all the work. And I'll show you what I mean by that in a second. So just a reminder, the term roots comes from solving for x in a quadratic equation. It also gives you, when you go do your back-to-school shopping, if you're in my class next year, go shopping for a root sweater. It's a little loophole in the rules there. It's not a loophole, by the way. Your other teachers aren't going to let you away with it. But I don't know, it's funny. A quadratic may have 2, 1, or no roots. We knew that from before, but just in case that slipped away, it could work out that we get 2 roots. And we often looked at ones that had 2 roots because they were the easiest one to talk about. But it doesn't have to be that way. You could do a quadratic that has exactly 1 root, but you can also have a quadratic that has no roots. And it really comes down to where 2, 1, 0. It comes down to where this quadratic is. And sometimes you can just look at it. The ones I made up in previous chapters, you go, oh, I can see that one. It opens upwards, and its vertex is down. Sometimes you can tell. And I'm going to do that in this lesson. I'm going to recover that. But sometimes you can't tell. You look at it and go, I don't know what's happening. So now I'm up to something, a shortcut. So without solving the equation, how can we determine the number of solutions? A quadratic equation in the form ax squared plus bx plus c equals 0. Someone says, can't I just do the quadratic formula? Won't that tell me? The answer is yes. And here's some examples that you don't have to copy down that we'll just talk about. I don't want you madly copying. And if you didn't do enough quadratic formula homework last night, here's some more good examples to go, you can look back at these examples to get some of that homework done in time for the test. And I made 3 quadratics that most people would not be able to look at and go, I can tell by looking at it how many roots there are. Most people would not be able to do that. So what I did is I did negative b plus or minus square root b squared minus 4ac, and I went through the steps. I found out what b squared minus 4ac was. This one happened to be root 16. Interesting, because I can root 16, and root 16 is 4, and I get 2 roots. 2 plus 4 divided by 2, which is 3, and 2 minus 4 divided by 2 is negative 1. None of that actually matters for today's lesson. But it's there for you if you have to do quadratic formula. That was a lot of steps. I'll do 3 of them in a row. That one had 2 answers. Let's watch this one, which only has 1 answer, and let's watch what happens. Something happens that is the hint as to how we know there's only 1 answer. This one, I did negative b plus or minus square root b squared minus 4ac all over 2a. So the b was 6. I did negative 6. In the bracket was 6 squared minus 4 times 9 times 1. And the denominator is 2 times 9. And then I got, in the brackets, 36 minus 36, which was 0. That's important. Because square root of 0 is 0. And let's just think this through. Just look at the numerator. What's negative 6 plus 0? Negative 6. What's negative 6 minus 0? Negative 6. The plus or minus sort of gets canceled out. There's no plus or minus anymore because you're plus or minusing 0. And if you're plus or minusing 0, there's only 1 answer. You only get 1 answer that time. And if your brain just clicked there and you're like, oh, that's pretty simple, except for it's in this really complicated equation. But the idea is simple. If you're going to plus or minus something, you're going to get 2 different answers. If you're going to plus or minus nothing, you're only going to get 1 answer. Picture right here. If there's a quadratic that just hits the x-axis and goes back the other way, you only get 1, 0. Yeah, that's graphically. You're asking graphically, not like we're doing it algebraically, but graphically, it's important to know these three in your head going, okay, it could happen. I could get 2, could get 1, could get 0. That way, when it does happen, you're not surprised by that, okay? Because that could happen. You could do this on the test, and you could get one answer, and you could put up your hand, Mr. Todd, I only got one answer. There's supposed to be 2. And then what would I say? I wouldn't know what to say. I'd be staring at you going, why do you think there has to be 2? I haven't done my job, or you haven't done your job, or something's wrong. Because quadratics can have 2 or 1 or 0. Now, this one, really weird. You sub in b squared minus 4ac. You get 3 squared minus 4 times negative 2 times negative 7, and you type it all in, and it says square root of negative 47. Now, let's just talk about that for a second. What number can you square root it? Sorry, what do you get when you square root a negative? That is, what number can you square and end up with a negative? No number that we know of. Hang on. Maybe that scared you a little bit the way I said that. No number that we know of. Okay? For us, in grade 10 and in grade 11, we'll just go, oh, so no answers. There's no way to do that. Because you're in 10 AP, I'll just say, there's no way to do that with the numbers we know. Yes? You're like, what? Numbers we know. I know all the numbers. Let's just rewind for a second. Let's just imagine we went on a class trip. This would be a great class trip. And we went to visit a kindergarten class. And I set up a one-way mirror. And you guys were all sitting in the stands, sitting out there behind the mirror. The class couldn't see you, but you could see me. What's that? Like an interrogation. It's like an interrogation room. I'm interrogating the kindergartens. First, you'd notice their energy. You'd be like, wow, they're jumping out of their desks trying to answer these questions. They're listening to every word, a lot like you guys. And then I turned and I said, okay, folks, can you tell me a number between 2 and 5? All the hands would rocket up, be pushing each other the other way to answer. Number between 2 and 5. They say 4. I'm like, that's a good answer. Good job. 4 is between 2 and 5. Now get ready. Get ready for what's about to happen here in this thought experiment. This is important. Then I said to them, and just before I said it, I looked at you, you're all sitting there in the mirror eating your popcorn, watching this, and I look and go, watch this. I'm like, tell me a number between 4 and 5. And they would go, we don't have any numbers that do that. There is no numbers between 4 and 5. And I'd say, that's correct. And I'd look at you like this, and you'd be like, your whole world's rocked. Like, well, what's happening? They don't know any numbers between 4 and 5. They haven't studied those numbers yet, so there's no way for them to answer, and they think I'm an idiot. They're like, there's no numbers between 4 and 5. You're like, interesting, okay? Thanks for having me in kindergarten class. And I point at you guys and go, let's go. That's all we need here. And I walk down the hall to the grade 2 class. And into grade 2, I go, watch this. I go, tell me a number below 5. And they say 2. I'm like, good. Tell me a number below 2. And they say 1. And I say, tell me a number below 1. And they say 0, and they're very proud. And I do the same thing. I look at you and I go, watch this. I'd say, tell me a number below 0. And they'd go, there's no numbers below 0. What's worse is, they're right. In grade 2, there's no numbers below 0. You know there's more numbers. Yes? There's often more numbers that we haven't seen yet, and it's not easy to explain. Imagine I went back to kindergarten and said, okay, let me tell you about some numbers between 4 and 5. How many classes do you think it would take for me to teach the idea of what the numbers are between 4 and 5? A lot. They might get it pretty quickly. I might be able to, with money, go, listen, you can have more than $4, but less than $5. It might not take me long to go, oh. But it would take a long time to understand those numbers. I got to do place values. I got to do decimals. Maybe I got to do fractions. It's years to understand the numbers between 4 and 5. Well, to understand the ones that square it to give negatives doesn't take years, but it does take months of intense study. Good news, after all that. No answers. The parabola does not hit the x-axis. After all that's done, hopefully you can see, and I'm going to get my orange highlighter here, that what really matters is what happens in here. I don't have to do all the work for the quadratic formula. All I got to look at is what's happening under the square root. If there's something there, I'll get 2 answers. If there's nothing there, I get 1 answer. If it's negative, party's over. Yes? Truly, for us, it's over. And here it is reviewed on the next slide. In the quadratic formula, the portion under the square root symbol, b squared minus 4ac, is called the discriminant. It's got this fancy name, discriminant. Its value can tell us the number of roots without doing all the other work. If b squared minus 4ac is greater than 0, then we'll have 2 roots. If b squared minus 4ac is equal to 0, we only get 1 root. And if b squared minus 4ac is negative, you get no roots. And you stare at the wall for a while going, what could all this possibly mean when I get a square root of a negative? But in grade 10, you just write no answers. Yeah? Next example says do it. Find the discriminant. Find b squared minus 4ac. So, just in case you didn't do enough homework, I'll remind you. In this one, the a I know for a while we were saying, oh, there's no a value in this question. We got to do better than that now. Yeah, it's an a value of 1. The b is 4, and the c is negative 7. Those are just the coefficients of the individual terms in standard form. Got to be in standard form. So now standard form's called in full circle. You're like, maybe standard form has a little more to offer than I thought it did. So b squared minus 4ac. I go b squared minus 4ac equals 4 squared minus 4 times 1 times negative 7. Punch that in my calculator, or actually do the work. 16 plus 28 equals 44. I'm going to double check that to make sure I didn't do anything wrong there. 16 plus 28 is 44. Oh, did you see me do that the second time really fast? I've done a lot of discriminants in my time. Yes? So I'm really fast at, I can look at an equation right away and just go, b squared minus 4ac, I already know what's going to happen. It's like peeking to the end of the book. Yeah? Flipping and they're like, what happens? Oh, the prince gets together with the princess. Good, I know how the story ends. Yes? For our purposes though, what does this tell us? Can you associate what we've done before with what I got now? How many roots would you get if it's root 44? 2 roots. And the reason that is because I will be able to go plus or minus. It'll be plus this, minus this. I don't know what the answers are. It's okay, though, if you believe. I think I would just do the quadratic formula. But this saves a lot of time. So we do it again. Here, a is negative 2. B is 3. C is negative 9. I calculate my b squared minus 4ac, which is 3 squared minus 4 times negative 2 times negative 9 equals, let me just make sure I did that right, b squared, 3 squared, yes, minus 4 times negative 2 times negative 9, yeah, it looks good. 9 minus 72. 72, negative times negative times negative is negative. Negative 63. What does that tell me about the sitch? No zeros, or no roots. Zeros is not wrong. When she said no zeros, that is totally correct. But I am trying to use that word roots as well, so you're ready for that. It's got something in your Christmas list for the fall, yes? Even if you signed up for AP next year, you might not have me for 11. I don't often teach 11 AP, but you'll probably see me second semester. Perfect timing. February, cold, perfect. These root sweaters are pretty good too, right? Big hoodies, and they got the fancy symbol. Big bucks. You can make your parents pay for it. How many people already have one? Huh? See, you're ready for grade 11. Got my root sweater. I'm not just being silly. I'm trying to help you remember the word roots. Yeah? So. One more time. A4, B4, C1, B squared minus 4AC equals 4 squared minus 4 times 4 times 1 equals 0. 0. 0. So there's 0 roots. Oops. So there's 1 root. Because I'll be doing plus or minus 0. And plus or minus 0 is a waste of time. You wouldn't do plus 0 or minus 0. They will both give the same answer. Is okay? You're happy? I tried to lay the foundation yesterday. While I was doing it, I'm like, oh, by the way, watch out for this. Yeah? Wait, something went wrong here. I want to fix that so my PDF doesn't look like a mess. Oh, it happened early. Oh, no. 1 second, I have to fix this. How did I miss that? There, yes. And then here, A equals 4, B equals 4, C equals 1, B squared minus 4AC equals 4 squared minus 4, 4, 1 equals 0, 1 rooty. Yes? He's fixed, so the PDF doesn't look like a giant disaster. All right. Mr. Tyler, I really get that. How can you make it harder? Well, I can't make it a whole lot harder, to be honest. There's not much I can do to that to cause you a problem, but maybe these two will cause you a problem. What's the problem with A in what we've been doing? Not standard form. So all the stuff we're doing here, and so this becomes a juggling act. When does vertex form work well? When I want the vertex. When does factored form work well? When I want the zeros. When does standard form work well? For a while, it was just y-intercept. But now it's if I want to use the quadratic formula. So I got to move these over. I'll show the steps. 2x squared plus 5x minus 8x minus 15 equals Zippo. And I get 2x squared minus 3x minus 15 equals 0. And now you can go back to being bored, because once I put it in standard form, it's just like the other questions now that I'm over in standard form. Let's just make sure I did it right. 2x squared minus 3x. Yeah, I did. And then so now use the discriminant. So I go b squared minus 4ac equals negative 3 squared minus 4 times 2 times negative 15. I'll show the steps. 9 plus, I already know what's going to happen here, friends. 9 plus something. I already know what I'm going to get, but I'll find the something anyways. 120, I think, and I get 129. Anybody on the case of their calculator to make sure Mr. Todd isn't losing it here on a, what day of the week is this? Tuesday? The discriminant's positive. How many roots? 2 roots. Therefore, 2 roots. Because I'll be plus something and I'll be minus something. Yeah? How about this one? I'll make you say it again because I don't want you to try doing the discriminant before you get this in the right. What's got to happen here? Standard form, right? And new respect for standard form now. Yeah? It's like, oh, okay, standard form, not the worst. So let me move all those over. 2x squared minus 8x plus 30 plus 2x squared minus 12x minus 5. Do you know that there are many people by the end of grade 10 that start to feel better about math? Like it seems like at the end of grade 9, it's like, why are we doing all this stuff? Why are they torturing us? But you're starting to see all the powerful math we can do just by moving stuff over to the other side and changing it from positive to negative and dividing by things. And you're starting to see, oh, there was a reason all those teachers were torturing us with all this, because the algebra skills are huge later on. Anyways, 4x squared minus 20x plus 25. 4x squared, yes, minus 20x plus 25. That's the best teaching I've done today right there in those few seconds. Double checking as I go so I'm not making these little mistakes that drive you nuts. I know you get your test back and you're like, oh, this is supposed to be a 3, not a 2. But I check as I go. And so now do the discriminant. B squared minus 4ac equals negative 20 squared minus 4 times 4 times 25. Ooh, I'm going to try and do it in my head, am I? Am I? Double check. B squared, yes. Minus 4ac, yes, is good. Negative 20 squared, that's not so bad. 400. minus 100, 400, 0. Yes? Therefore, 1 root. I know it's hard, right? 0 means 1 root. It's awfully tempting to say 0 roots, but if I'm going to be plus or minus 0, plus or minus 0 doesn't give 2 different answers. Therefore, 1 root sweater. Do you know who that is? Well, it is Dracula. He's the Count. Count. Oh, yeah, Count Chocula. I miss Count Chocula. I loved when I could eat sugary cereal first thing in the morning. Blueberry. And there was a third one. Frankenberry. Frankenberry, too, yeah. Do they even make this stuff anymore? Got outlawed at some point. Like, hey, come on, what are you doing to your kids here? Like, come on, you can't open their mouth and pour in white sugar and think that's going to go. Oh, why don't you just give them 2 Pepsis for breakfast? You know, like. Good questions here. What's left? What's left? Oh, I know what's left. I peeked. Here's what's left. So you're like, okay, I get it. Anytime I want to know a number of zeros, I'll just do the discriminant. No, it could be easier than that. Let's go back and look at what we could do before this lesson and remind you that, no, you don't always have to do that. Sometimes I can just look at it and know. You're like, I can't. I'm like, oh, I think you can. I think I can look at some of these. For instance, this thing right here. I think I can look at it and know what's happening. It says, using a sketch. Now, these 2 words are not quite interchangeable in math. When we say make a graph, we mean make a beautiful graph. Get the vertex, get the 135 rule. I want exact points. If you don't have all the exact right points, I'm going to circle it. I'm going to mark it wrong. We need exactly. When we do a sketch, you're like, hey, what's going on here? Just a quick sketch of what's going on here. Where's the vertex of this thing? Almost. Good. 3 and 11. Yes? So it's over here and up here somewhere. This is what I mean by just draw a sketch. I'm not trying to do the scale. 311's over here somewhere. And which way is this opening? Upwards. How many zeros does this thing have? 0. No zeros. No roots. Notice I've changed the word. You're like, why are you saying zeros instead of roots? It's subtle, folks. If I'm dealing with a graph, I usually say zeros. If I'm dealing with an equation, I usually say roots. Are they different? Not really, but it is a different situation, so I'm using a different word. All right, this one. What can I get easily from this without doing any work? Just look at it. I don't think I can get the vertex. The x values. Yes? X equals 0 or x equals -6. Now, I know which way this opens, but I'm done the question. It says how many zeros are there? When it's in factored form, I can see there's 1. There's 1. I'm done. 2 zeros. And the direction of opening is irrelevant. I'm not saying you couldn't do the direction of opening and open it upwards and do a nice sketch of the graph. You totally could. But when it's in factored form, I don't need the quadratic formula. I don't need the discriminant. I don't need standard form. I don't need anything. What are the zeros? 0 and -6, 2 zeros. I'm all done. Okay? That's what I was saying. Just go for the discriminant? Well, yeah. But it might be easier than that. So as you're doing the homework question, look at each one and go, can I do this easily? No? Discriminant. 3x squared plus 5. Who's got this? What does this thing look like? Where's its vertex? Zero and 5. It's up here somewhere. And which way is this thing opening? Upwards. How many zeros? None. No zeros. How about this one? Where's the vertex of this one? Close? Right, yeah, just what we talked about a few minutes ago, right? 1, 2, 3, 4. It's at +4. And there's the vertex. And which way is this opening? Downwards. How many zeros? 1 0. answering the question that came up earlier is how can it have 1, 0? If it hasn't been moved up or down, if it's just been moved left or right, you're only going to get 1, 0. That covers everything, doesn't it? There's examples with no, with 2, with 1, and those are faster than doing the discriminant. Because look at, if I had to do the discriminant on this, can you imagine? Multiply out the brackets, collect the terms, multiply by -5, then do the discriminant. This is way faster. So try to have some wisdom there. Don't go directly to discriminant. Use the stuff you already know if it's not in standard form. Yeah? If it's in factored form or in vertex form, you should be able to do it without making the discriminant. That's all right. For Thursday, will we need the formulas? Right after I finish this lesson, there's 2 things we need to discuss. We need to discuss equations, formulas, and test day. Good? Those 3 things we gotta, and we need answers now, Mr. Todd. No more playing around. Tell us the sitch, okay? What else could there be? Oh, a word problem. Yay! Why does this word problem make me a little bit happy, though? It's in standard form, but they gave the equation. I don't think those are the word problems you got to worry about. I mean, you got to study them, yes, but those aren't the ones that are going to freak you out. The ones without the equations are the ones that you're probably stressed about. Okay? This has the equation, so we put the stress on the shelf, and we'll come back to that in just a minute. The formula, oh, we've seen this. Ones like this a million times. The height is given by -4.9 t squared plus 60t plus 3, and it models the height of a projectile on Earth because that's -4.9. Different planets, that number will be different. Yes? Where h is the height in meters and t is the time in seconds. Someone really clever goes, does that number change, -4.9, as I go high in the mountains? And the gravity number changes? Yes, but not by a whole lot, really. Okay, so on the Earth, you wouldn't have to change that by too much. How long would it take the rocket to fall to Earth? Round your answer to 2 decimal places. Set h equals, if we're going to be on the ground, the height's going to be 0. You're like, that fits right within what we're doing. We're doing zeros. Yes, this question is the question we've been working on. Find the h-intercepts, basically, is what I'm doing. Okay, so here I go. 0 equals -4.9 t squared plus 60t plus 3. You should be unimpressed. You should be like, I did my quadratic formula homework. Isn't this just, let's just do the quadratic formula? Yes, and here's why. Because this does not factor nicely. Yes, -4.9, 60, and 3, like these numbers are not friendly at all. And you'll find in grade 11 and 12, a lot of those students are quick to use the quadratic formula. They look at it for only a few seconds and go, do I think I can factor this? I don't think so. Quadratic formula. Yeah? That's the wisdom that's coming as we go along here, is that we won't wait long to factor unless we're told to factor. Yes? So here I go. A equals -4.9, B equals 60, C equals 3. The A is the coefficient on the squared term, the B is the coefficient on the not squared term, and the C is the constant term, the number that doesn't go with a variable. That's why it's called constant. It's not with a variable. If you signed up for physics next year or chemistry, this is coming right at you. Both those courses require the quadratic formula regularly. Yeah, regularly. Okay, so here we go. Do you know it? Do you know it? It's one of those formulas that if you did a lot of the homework, you might have memorized it accidentally. I didn't even make any effort on it, but I remember it. Josh. Good. It's bad. It's bad. But you use it so much, it's worth it. Yes? When you memorize that thing and you show up in chemistry or physics and they just break it out and go, oh yeah, quadratic formula. Oh, you learned this last year. And you're like, oh yeah. I missed something on purpose. What goes on the left side? X. And if you write X, I'll mark it right. But technically, in this question, I'm looking for t-values. So I'm not setting up to take a half mark off. I'm not. I'm just telling you, yeah, the x is the general version of this. But in this case, I wanted t-values. So then I go t equals negative 60 plus or minus square root 60 squared minus 4, negative 4.9, and 3, all over 2 times negative 4.9. Now listen, friends. Some of you have a calculator that either has the quadratic formula built into it or can be programmed into it. Let me tell you the math version of this, how many steps we require. We require a sub-step, a simplification step, break it into two, and the answers. We need to see those steps. So for instance, we need a sub-step. I did that. A simplification step. So we allow you to use your calculator to simplify the discriminant, that mess that's under the square root there. So it's, what do we got? 60 squared minus 4 times negative 4.9 times 3. And I get 3,658.8 all over negative 9.8, because I multiplied the 2 times the negative 4.9 there. I just want to type that in again because I don't want to make a little mistake here. 4 times A times C. 3C, okay. Then we need to see this, break it into two. Step, t equals negative 16 plus root 3658.8 over negative 9.8. Or t equals negative 16 minus 3658.8. Negative 60, look at it. It's a 60. Silly Mr. Todd, thank you. And some errors are easily fixed, future calculus friends. Sometimes we can just fix it all the way down, and other times it just completely screws up everything. And you get your big eraser out and you go, okay, it all goes, and I'll try it again. But this time I escaped. And then the final answer is t equals, or t equals, and I'll get my calculator to do that work. Let me find my calculator. Calculators. And this is a Sharp. Many of you have a Casio. But I think the steps on this Sharp are pretty much the same. Fraction button. It's negative 60 plus root 3658.8 over negative 9.8. Answer, negative 0.05. No, how many decimal places? 2. Yes, negative 0.05. And then the other answer, I just go up or back, and I change that positive to subtract. And I get 12.29. Hold on. Why is there two answers here? Okay, let me show you. Let's get Desmos out and really get to the bottom. It's the bottom because it's where it hits the ground. Really get to this question. www.desmos.com, graphing calculator. Y equals negative 4.9x squared plus 60 plus 3. Oh, can't see what's happening. Need a better scale. Okay, over to scale. Turn the x-axis from negative 2 over to 15. Turn the y-axis from negative 5 up to, what's the highest it gets here? 40? No. 50? No. 100? No. 200? There it is. There's a nice picture of the parabola. Now, Whatever this object was, it got fired in the air and came back down. Technically then, my equation that I'm using, that parabola, is showing parts of the parabola that don't really apply to the situation. For instance, this parabola doesn't fit the situation after it hits the ground there. See? After it hits the ground there down here, this parabola doesn't fit the situation anymore. I really want the parabola to stop at that 12.295. And look, that's pretty nice for me to check the answer there. And it doesn't apply, this parabola doesn't make sense for before this thing got kicked. So this negative 0.0498, even though it's on the parabola or the equation I used, we really should do better here. And we're not going to do that in this course. But really I should say this equation only works between time 0 and time 12.29. We will get to stuff like that. And we'll start saying, okay, well, only use this for these t values. But I just mention it now and just mention that, yes, that's what's coming. So we don't, this is not, no, that's not the one we are looking for. Therefore, the object, the stone, the model, the projectile hits the ground at 12.29 seconds. Do you have questions? Okay, well, if you've drifted off to sleep on me, you might want to come back for this last one. Widely known as a very tough question. But it's not. It's not. I'm telling you, if you pay attention, there's only one new thing in the whole darn question. Ready? On what time intervals is the height of the projectile over 150 meters? Sub in, yes. Set h equals 150. The equation will find zeros. But the equation will find 150s as well. So I put a 150 over here. Negative 4.9 t squared plus 60t plus 3. Let's just make sure I copied that down right, because I made a mistake in the previous one, didn't I? Yeah, there. Now, friends, take a moment. Take a deep breath. Do your inner chi breathing. Look at that equation and decide if it's ready for the quadratic formula. And after you decide that it is not ready for the quadratic formula, decide what I have to do to it to get it ready for the quadratic formula. Bring the 150 over. See, this question people find very difficult because they go ahead and they put the 150 over there, or they ignore the 150 and they go, okay, here I go. Quadratic formula. Like, no, you're going to find the zeros. We want the 150s. One move. I'll write it in red. Just one move I have to do to get this ready for quadratic formula. Bring over the 150. Some people will argue that's because we want 0 on one side. They are correct. Other people will argue because it's not in standard form. They are also correct. This thing needs to be 0 equals negative 4.9 t squared plus 60t minus 147. Does it look like fun factoring? No. Yes? Incidentally, our last quadratic lesson. I'm moments away from being done quadratics for grade 10. Aren't you excited? We'll move on to triangles. Yes? Nice look. She's over here. Ugh. Well, let's not wait around till tonight to find out you don't know what you're doing with the quadratic formula. Take a moment and try and do quadratic formula. I'll do the steps. I'll be up here doing them so you can look to see how you're doing and make sure. But try to use quadratic formula on this thing to see how it goes. After it completely disappears there? Okay. I've done the first step for you. I've picked off the A, B, and C. Challenge yourself Try writing down the quadratic formula to check what you have memorized. Maybe you sort of have it memorized. There we go. Okay, write down quadratic formula. Sub it in, sub it in. Where's my quackamallator? My quackamallator. $718.8? Anybody else? $718.8? Yeah. Write the separate pieces. So, here come my two t values. $3.39. Did you get 3.39? And 8.86. Is that what you got? Yeah? Nodding? Smiling? No? Shaking your head? Like, what did I do wrong? Type it in again to see. So it says on what time intervals is the height of the projectile at or above 150? Between 3.39 seconds and 8.86 seconds. In grade 11, we'll start writing this like this. But you're not responsible for that. I just mention it, that we do have some nice notation coming to help you to write intervals. But you can just say between 3.39 and 8.86. So how long is it above 150? You just subtract the two to find out how long that was. 8.86 subtract 3.39 equals 5.47 seconds. Okay? But yeah, I pause for questions. I'm not acting like that's an easy question, because it's not. There's a lot going on there. So if you have questions, now's a good time. Quadratic's over for now. What's different in grade 11? A lot more focus on the fractions. Yes? That's one thing that comes up. So challenge yourself. I know some of you went right to decimals on the quiz. Challenge yourself to try to stay with the fractions. Yes? Because that's what's coming. I will stop the video and then we'll